All right, we're going to go ahead and get started. Welcome everyone, both in person and online, to our third session for our Generative AI in Scientific Software and Coding Workshop series. Before we get started, I do want to go over our code of conduct. Because this is a hybrid session, please be respectful of the peers, of the other participants online and in person. This will be a rather interactive session today, so please be mindful. If you run into any issues, please contact me, Jessica Wang, or Tasia Peterson if you experience any issues or have any questions. We have another session confirmed, session 4, which will be in a couple weeks, November 13th from 2 to 3 p.m. Mountain Standard Time. This will be fully virtual. It will be on debugging scientific code with LLMs using GitHub Copilot for debugging. Our speaker will be Supreet Suresh, who is internal to here at NSF NCAR. And just as a reminder, if you have not registered, please be sure you do register. You only have to do it once. But by registering, you do get calendar invites and reminders for all of these events. Now I'm going to switch it over to Ben.
Thanks. So Jessica just mentioned what we have confirmed. I'd like to just spend a brief moment and talk about what we have envisioned for the rest of the series, the rest of the year. After session 4, and these are still in the planning phase, so this is our intent but not booked yet, we're looking at least 2 additional final sessions to round out the series. So we understand that the community is very, very interested in energy and environmental impacts of LLMs, not necessarily just code generation, but the entire space. So we have some leads on that capability, and we're pursuing that. We don't have a date to advertise yet, but our intent is to do that maybe in the later November or early December timeframe. And whenever we're all done, we do want to have a wrap-up session. So we definitely would like to have some open discussion at that forum to get some input from you all. What are your first impressions? Maybe we can have some fun with some of the pitfalls we've experienced using this technology thus far, initial user experiences. But also want to spend a few minutes and talk about beyond code generation. There are other tools, of course, beyond Copilot and its kin, I would say, that may be useful in scientific workflows. And so we'll at least identify some of those and point people out to the field. And as a reminder, if you have any other requested topics or there's anything else you'd like to know a little bit more about in this space as you gain experience, please let us know. You can reply to the surveys that you get after each session, or just speak up. And then finally, I wanted to take just one moment and kind of highlight about how quickly this space is moving and address some of the questions that have come up already. We've gotten a number of flavors of about, is GitHub Copilot the best, or what about this other model, or that sort of thing. And the take, and I think we captured this last time, is it changes month by month, certainly quarter by quarter. And these 2 news articles for the past couple days. So as of now, the Copilot tool that we've talked about already is branching out beyond just the OpenAI series. They're allowing Claude and Google's Gemini models as well. So I expect to see this sort of behavior going forward. You can sort of think of Copilot as the front-end interface that gives you a consistent API, so to speak, and then at the back end deals with whatever the most popular and capable models are of the day. So since that question had come up previously, I just wanted to go ahead and address it quite clearly. Both of these are linked to the news articles, so you'll get the slides after today's session if you want to read more about that. All right, thank you.
And now I'm very pleased to introduce our guest speaker, Dr. Nicholas Klassen. He comes with an interdisciplinary career and has bridged the gap between humanities and technology. He has a master's degree in history and a PhD in cultural studies. He has worked in a software research institute, a tech startup, and held several data analysis roles at Google, where he currently works today. He recognizes the critical role of education in AI ethics, and so he conducts bi-weekly workshops on the subject at the Atlas Institute at the University of Colorado Boulder and regularly acts as guest speakers in seminars. His work focuses on fostering understanding of the ethical implications of AI in both academic and professional settings. Please help me welcome Dr. Klassen.
Thank you all for coming. Also, everyone online. I'm not sure where the camera is, but yeah, I'm very grateful to have the opportunity to talk to all of you about a topic that's very important to me, and I think it's also, if I may say so, very important to our society at this current stage, right? we're just talking before the start of the seminar here, like how fast the space of AI, especially in the generative models, is developing. And it's very hard to kind of keep track with everything that's happening. And I think that makes it sometimes hard, especially as researchers, but also in the professional world, obviously, to keep track of, okay, what are actually all the regulations? What are like the ethical codes that we should uphold? And also how does this impact the quality and kind of, just the integrity of our work that we're doing. So I want to talk about these three aspects today in my talk here. I would really love to make this a little bit more interactive as possible. So whenever you have any questions, just interrupt me. On Zoom, you can just raise your hand and we'll have help here to bring up these questions. And really rather, if you have something that's bugging you or something that you want to go into more detail, just let it out and we'll try to kind of focus on questions as much as possible. Thanks. Yeah. As you all most certainly have seen, AI is having a very big year. This year, it's not just all the breakthroughs and kind of the technological development, all the AI companies kind of, growing insanely fast. OpenAI becoming the most valuable startup ever imagined. And then also AI actually winning big at the Nobel Prizes, which was not uncontroversial in many scientific communities. It was also interesting that 3 of the 5 researchers that got the Nobel in chemistry and physics were related with a private company, namely Google, the company that I'm working for, but I do not represent Google here today, so I will not be salesy. In any case, so it seems like this is the time of AI, right? And AI is kind of, winning prizes left, right, and center and turning the world upside down. So what does that mean for us mere mortals, that don't build AlphaFold and all these other models and understand how this technology works to the detail? How do we engage with that, right? In our day-to-day, in our research, whatever we do, how do we use that? And that's what I'm kind of want to focus on. As I mentioned, I've brought 3 areas that I want to kind of highlight here. The first is legal compliance. The second is research ethics, and then it's standards of good research. As this Venn diagram kind of suggests for me, those are kind of expansions of each other. Ethics obviously contains being legally compliant, but it contains more than that. And good research practices contain following ethical rules and standards of our field, but also things that just are personal and also for our research integrity. Yeah, so the first area is laws. And within laws, I want to focus on 2 specific areas. The first is developing foundational models. That's probably a little bit theoretical. I don't know how many people here are working on actual models, but it's still important to know what the regulations are for the models when they are built and when we use them, right? And the second one is what I call fair usage. Let's take a quick look at kind of a couple of the major AI regulations around the globe. What do you notice when you look at this slide? None of them are actually already enacted. Everything is proposed under review. In the UK and Japan, it's even just called guidelines. As we've known for the last probably maybe 150 years, right? Technologies in the private sector move very fast. Institutions and the public sector move very slow. And that we see that especially now where kind of governments and public bodies, they're just kind of scampering to try and catch up with AI. And obviously there are 2 sides to this, as there are always, right? The first is we want to protect the public, we want to protect people using this technology. But then there's also this feeling we don't want to fall behind. I left one very big actor out of here because it's a little bit difficult to actually define that position. That's China, right? Especially in Europe and here in the US, there's also this feeling if we regulate too hard, China will beat us. And so that's kind of, it's a bit of an uneasy balance in public institutions. How far do we go with regulations, and how far do we just accept that people will probably be, in some form of danger from the speed that this technology is developing? Go ahead, yeah.
Do you know, is there any action on like the WTO or the global bodies? Or is it just, they're just too slow? Because it seems like if any place for this technology, it's beyond borders.
Yeah, there are a couple of initiatives more on the UN level, and the UN itself has actually released guidelines on ethical AI, and I find them pretty helpful if you want to look them up. But again, they're very, very broad, and they have to tread lightly, partly because of the kind of technological arms race. So it does not entirely kind of eliminate that problem of national interest. I mean. It's still very, even if none of these big kind of AI regulations have been enacted yet, it's still important to look at them to see, okay, what's the gist of where this is going? And there are a couple of things that are very important for us to keep in mind because they are most likely going to be implemented. And these are regulations that we will most likely be kind of experience as actual laws in the near future. And one of the biggest things that these regulations and these laws kind of grapple with is that they want to mandate accountability for what they call high-risk models. The problem here is obviously a problem of definition. So what are high-risk models, right? If we're building models, if we're training off-the-shelf models for specific use cases, or if we're using models, how can we determine what high risk is? This is where kind of this is part of the reason why the laws are not yet enacted, because this is where a huge debate is happening. I've written a couple of, for a couple of these regulations, I've written how they define kind of these high risk, or sometimes they're called foundational models. And you can see they're very similar kind of systems that can perform different things, systems that can perform things for which they were not originally trained, systems that can make decisions, kind of systems that can act in a certain way autonomous. In California, people are very pragmatic. So they said, we'll call a high-risk model everything that costs more than 100 million to develop. It's like, yeah, what if the price of the CPUs changes, right? It's kind of, it was also blocked by the governor, but that shows just the problem of defining what do we deal with here? Kind of how do we find categories to put guardrails and rules around this. I think in our everyday usage, right, we mostly have like maybe 5 models in mind: ChatGPT, Claude, Gemini, maybe Mistral, and we know that these are like foundational models, highly general, highly multi-purpose and stuff like that. But especially when you do research, there can be some kind of sub-models or smaller models that are trained for specific purposes. And around these, it's always difficult to say, okay, do they fall under this high-risk category? How do I categorize them? Why is that important? Couple of things I want to note here. So for high-risk models, most of the regulation is around high-risk models. And for high-risk models, there is some special kind of requirements when you build them, and also some special requirements when you work for them, right? So that's what I call fair usage. The regulations around fair usage, they mostly apply to these foundational or high-risk models. The most important part, and that's what we all struggle with, right, is fair usage means transparency and attribution. Transparency means we actually know what a model is doing, and attribution means we actually know that a model is doing that. So that idea or ideal of transparency obviously cannot be fulfilled anymore with foundational models. Even researchers that I know working at Google or Amazon, they don't know exactly how these models work, right? There is a black box element to it. If you have like billions of tokens running through, billions of nodes in an artificial kind of, virtual network, it's very hard to say what's happening there. So transparency, when we talk about transparency nowadays, it's actually mostly describing the model architecture and noting that somewhere. So once these regulations are enacted, we should all be able, for instance, to go onto Google's website, look up Gemini, and then see a description of the model architecture that they're using. Transparency also means, and this is very, very important, your training data set. Again, it's a little bit difficult, the training data set is all the internet in many of the models, but there are more requirements around that. So if you build a model, or if you use one of these foundational models, if you talk about transparency, it's what's the data set that this model has been trained on. It's very important. They're actually kind of defined data sets. They're described and everywhere. It's actually worth looking them up sometimes if you have a couple minutes to spare, because obviously the training data is 90% of what comes out in the end. Yeah, and there was a third part, yeah, risk mitigation. Exactly, yeah. So if you develop a foundational model, and this is really just if you develop one, you need to use certain training techniques that called adversarial training, right? Where you actually are required, will be required by these laws when they will be enacted to try and break your model or make it do some bad stuff. So normally when we work with these models, we should expect that they have been trained in that way, and they should be they should have guardrails in place for not making actual criminal mistakes. So let's hope that these laws will kind of achieve that. Yeah, I think in part, kind of what I wanted to highlight with this cartoon here, where this is a little bit relevant for us as researchers. When we build like specific models, or we take an off-the-shelf model and we train it for something, and then we use that where kind of normal people are involved in our research. Think of, psychology studies, think of social science studies, think of health studies, medicine, wherever, you interact with people, where you do experiments or focus groups or whatever, whenever people are interacting with the bot, we actually need to let them know this is AI. You're talking to an AI maybe, or this is generated, you're interacting with a generative model or stuff like that. That will be part of the transparency and attribution requirements, for most of these laws when they will be enacted. One of the things I want to say, and I'm very excited to talk to scientists, is that one of the biggest challenges around building and using kind of AI models is that they are so fast moving. But in my opinion, science actually has a huge advantage. You all have a skill that is unfortunately lacking often in the private sector: documentation. You're all used to have lab notebooks, right? Document your research, write things down, take pictures and stuff like that. And we need to bring that mindset to the use of generative models, because documentation is kind of very, very important. And the requirements for documentation, as far as I can tell, they will just become more involved. Again, that's much stronger on the side of building the models, but even if you kind of, as I said, you take an off-the-shelf model and you train it for a specific use case, I would start documenting along the process all the time. Partly for the own research integrity, we will talk about that, but partly also because some of that will be required by law eventually.
Question, or anybody online? I'll take another.
Yeah, go ahead.
Curious in that regard, where's the model's responsibility in that, right? One thing that our science community does focus on is reproducible research.
Yes.
And make it very easy for people to reproduce your numerical experiment or anything else. If you give the same prompts to a model on different days, you're going to get different outputs. It's clearly a known issue. Is that on the radar? Is that expected to be? How do we do that?
Yeah, I'm going to talk about the so-called crisis of reproducibility a little bit more.
Okay.
But yeah, that's definitely one of the reasons why documentation is so important. I was kind of, trying to be extra smart here on this slide and give an example. I generated this cartoon with a certain model within the ChatGPT family on this day, and this is the prompt I used. That doesn't mean that you will get the same result if you put the same prompt in, right? That's one of the biggest weaknesses of working with generative AI models. The output is within a certain boundaries, is unpredictable. Yeah. So that's why documentation is so important. Go ahead.
So I think we need to be a little bit careful if it's numerical reproducibility. So if you say 2 + 2, it should always be 4.
Yeah.
But if you have a prompt where you say, where creativity can play a part, so it could come up with a different picture, and we don't need reproducibility in that context. So can you kind of elaborate from that perspective?
Yeah, as I mentioned, we'll talk about a lot of this further down when we talk about ethical guidelines and also just practices of good research. As I said, in terms of the law, for now, it's important to know that documentation is the best kind of way of dealing with that. Documenting all the prompts, documenting the output, even if you cannot reproduce it, you can definitely say within a certain kind of, limits of certainty, okay, yeah, this makes sense that the model that was used on that day with this prompt came up with this kind of output, and that fits the general pattern of what can be expected, right? That's what the lawmaker cares about at this point. Yeah. Thanks. Go ahead.
I have a question about the data. So eventually, I think all these LLMs or all the generative AI tools, at least, it comes down to the data set that has been used and the compute power. And in the end, the person with the or the entity with the most data and with the most compute, they'll win the competition. So how does that, do you think, encourage, like at NCAR, we care a lot about like open source, open science, providing as much documentation and information for the users. But how do you think that would impact this culture of like openness, providing the data, all the data, research data, scientific data out there?
Excellent question. Yeah. Again, from a legal perspective, the lawmaker doesn't care that much about the differences in the data sets and stuff like that. For the lawmaker, it's more important to say, okay, we use this training set. It contained these data points, and we use these and these methods of collecting them. Unfortunately, as sometimes with these regulations, the AI acts, they will probably make it a little bit more difficult to get transparent information about data sets, because companies will try to limit the information they share. The more they share, the more obviously vulnerable they make themselves, right? The more information is out about the data set you use, the higher the probability that you have actually violated some regulations around data collection or not. So that's going to be part of that tussle between the private and the public sector. It's kind of, obviously not by chance that the governor of California stopped the proposition of this law that kind of, wanted to put strict guardrails around models that cost more than 100 million. Because all these models that cost that much are mostly developed in California by companies having the headquarters in California, right? So they were already afraid that they were going to kind of, lose out in the arms race, in the technology arms race. Yeah, so unfortunately, my guess is that we will see less openness the stricter the regulations will be. But that's partly what these lawmakers anticipate, right? And that's why they try to be very specific about, you need to provide these and these and these information about the data set that you're using to train this model. And also let us know how you collected that and where you collected that. Yeah, any other questions around the legal aspect of generative AI? Then I want to move on to the second part, which, as you remember from the diagram, is even bigger than legal compliance, and that's working with ethical guidelines. Just a quick word on ethics here. I don't want to do a full definition or whatever. This is not a philosophy seminar, right? But I think we should keep at least two things in mind when we talk about ethics. Most research areas that I know, they have something like, ethical standards of research. Probably more in social sciences, maybe for experiments or medicine. But regardless, there are like specific standards within your field, most likely. But then there's also the general kind of public understanding, right? That every person on the street would understand when we talk about ethics. That's around making good decisions, or not, kind of not doing criminal things, not doing bad things with AI. And I think, both of them are important here. So I'm going to use them a bit interchangeably, but just want to highlight that there are these two elements to this. I want to point out two aspects of ethics, because AI ethics is a very, very big field. So if you have questions that are beyond these two topics that I want to touch on, please just go ahead and bring them up. Here I want to focus on bias mitigation, which is probably one of the biggest ethical challenges when working with AI and large data sets. And then the other one is traceability and attribution. That's probably more of practical interest. Let's start with bias mitigation. So I don't know if any of you remember, like before the hype of generative AI, the big AI player on the block was IBM's Watson, a system that barely exists anymore today, but Watson kind of won on Jeopardy. I think it was maybe about 10 years ago or so, which was one of the big breakthroughs in natural language processing. And moving on from there, IBM actually had this whole idea that they would build multiple sectors where AI would become a game changer. And one of the biggest one that they kind of worked on from the start and that spectacularly failed was Watson Health. And one of the examples, one of the things that brought down Watson Health is the example that I brought here. So Watson Health was used amongst other use cases to build a model for cancer detection. And the idea was, right, that you not only take structural data, like metrics that were taken from patients or lab results, but also the unstructured data, interviews between the physician and the patient and text notes and stuff like that, and throw it all into the model, and the model would help with cancer prediction. So IBM Watson, they worked with just one institute, and actually mostly with the 2 physicians within kind of that project, and they realized right out of the gate, they didn't have nearly enough data to feed a model based on the patients that they were treating in that specific institution. So obviously they're smart people. What do? They create synthetic data that kind of, simulates what cancer patients look like, feed it into the model, and then spit it out in the world. And then they made a test in hospitals in Asia. And you can see when you get to South Korea, it was less than 50-50, the prediction, how well the prediction of the model matched the prediction of an actual physician. So if you had flipped the coin, you would have been very slightly better off than by trusting the AI model. So obviously one question was, how did that happen? It's become a pretty iconic case study at this point. The researchers, they were generating synthetic data based on the profiles they had in their database. And that was from, as we all know, hospitals, they're in specific demographic areas, maybe specific income areas. There are many kind of factors that can skew a patient set in a clinic. These researchers had completely ignored that their data was very biased. So what they did was they basically just amplified all the biases they had in their data and blew it up into gigantic proportions and then threw it into the model. And it's no wonder that the model spit out that biased data again. I think there are many, many examples like this, right, where people go in with the best intentions, and then something spectacularly fails and we realize, oh, it was because there's bias in the data. That's partly why even in the regulations that I've mentioned, detecting and kind of counteracting bias will be part of the regulations at some point. But I think beyond the regulations, for me, one of the first things to do when working with generative AI models, when working with these large foundational models in general, is be careful of biases in the data set. And the reason why it's often so difficult to naturally come upon that is that biases are just hard to detect. Our brain builds them like the heuristics, if you want to use a more neutral term, because they're useful to us. They help us deal with very complex situations and help us process highly complex data sets much faster. So it's very often very difficult to see our biases reflected in the data, for instance, that we're working with, or in the models that we're working with. I don't know about any really good tool that can help. I'm not sure if any of you followed that, but right, when Google Gemini created an image generator, they were trying to kind of, reduce bias in image generation, like specifically racial bias and gender bias in image generation. And they put in a couple of what they thought were great rules into the model. And so when you ask the model, generate images of German Nazi soldiers, it kind of, put Asian American women into those uniforms. So that's obviously a spectacular fail. That's not how to do this. There are no, as I said, there are no really good fail-safe methods of detecting and kind of, counteracting bias in our models. I brought something like a rule of thumb that I want to share with you, but obviously this is not going to cover all your specific use cases. Just to kind of mention this, when you go into a use case where you use a model trained on a large data set, if there is a specific reason why the data was different in the historical setting that it was generated than it is today, then there's probably a bias in the data, right? I'm more familiar with the commercial kind of examples, the Apple credit card, for instance, where women had by default a much lower credit score than men, stuff like that. I'm sure you will be aware of examples from your field. But yeah, I cannot stress this enough. Detecting bias in your data set, in your model, and counteracting that is one of the kind of the primary things we need to do when working with AI. Any questions around that? Any other examples? Go ahead.
Yeah, I'm just wondering from a practical perspective. I mean, with like smaller LLMs, I can imagine maybe getting my head around the data that we're fed to them. But for something like ChatGPT, when it's basically like the entire internet, it's got to just be a black box at some point. And so I'm wondering how we can make use of this rule practically.
Yeah, that's a very good question, right? When you use a model like ChatGPT, especially kind of the later generations, what makes it even a little bit more complex is that they have their own bias detection by now. So they have their own mechanisms of kind of trying to counteract the bias in the data that they don't share. So we don't know what that is. In my experience, the best thing to do would be to do a couple of trial runs, play around with prompting. Most of the kind of later stage models or like further generations, not the early generation models, you can actually add things like, what's the bias in the data set in the prompt, and it will actually kind of give an answer. Whether it's the right answer or not is for you to decide. But it's for sure, one of these things when you work with a large data set, start by playing around with the data and see what it spits out to you and see if you can detect a bias, right? Just it's a little bit of kind of, experimenting with what you have.
Be a different form of a bias question. So I'll start with an anecdote that leads to a question. In 2001, I went to Germany for the first time, and I was visited by a grad student I was collaborating with. And I was floored to learn that he had published his dissertation in English. And then later, he wound up as a referee on some articles and corrected my English. It was a fantastic experience. But is there a language bias in the technology at present? Like, I don't know what fraction of the internet is English. And does the technology, is it being equally applied? Does it work just as well in other language character sets? I'm thinking of Japanese, Chinese character sets, things of that nature.
Yeah. And again, thanks for bringing that up. There are huge differences. So part of the problem that you mentioned is that I think like 60% or so of the internet is in English, if I'm not mistaken. Like the internet, what's that, right? But if you look at large kind of scans of the internet that are used for training foundational models, most of them, like these data sets you will find, they will be probably about 60% English. It really depends on the specific language, how well kind of that's represented in these data sets. I know for a fact that Japanese has caused huge problems for Google internal models. It seems to be going better nowadays, but even with ChatGPT 4, if you try to have it translate stuff, translations are still pretty crappy, even with these big models. So language kind of, cultural translation between languages, cultural differences, difference in references, difference in styles, stuff like that. It's very difficult for these models to deal with for sure. Yeah. Sometimes it can be beneficial if you are multilingual, try and work with different languages in the same model. You might get different output.
I have a question. Since the data set for training these models is not clear, and we also don't know if like the answer that the model gives is like a hallucination or a true answer, how can we mitigate the risks of just propaganda or false information, especially like about a culture or about like languages that are like not represented as much in for training these, and especially because the training data set is not clear, whatever is not there probably is like the LLM is going to make up something for it. So yeah, how can we detect those and how can we not fall for it?
Yeah, excellent question again. And unfortunately, again, there is no kind of surefire answer, or there's no silver bullet for that specific problem. Part of these regulations that I mentioned, they mandate a technique, as I said, adversarial training, right, for foundational or high risk models. And part of what this adversarial training does is it does actually, try to, write prompts or kind of interact with these models in any way that they kind of reproduce negative stereotypes, reproduce biases in the data, reproduce, all that hate and negative content that we unfortunately see online in huge masses. How well they succeed, that's kind of always in question, right? Especially because there's always the cycle, right? If you have something that counteracts the spread of false information, for instance, the agents that want to spread that false information, they will find a way to kind of counteract these barriers in their turn, right? So it's a never-ending story. I think part of how this has played out actually in the last couple of years is very often the public. So one of the things I'm often interested in is just kind of, scanning certain blogs, maybe certain sites, certain journalists that I know that deal with this information, and just pick up on things to educate myself about, okay, oh, there's a new type of bias that somebody found in the data, or, there's a new way that you can make a model behave in a criminal way, be aware of that, right? Again, education is, unfortunately, for most of the issues around AI, education, self-education and educating others is 90% of what we can do.
That's great. Thank you so much.
Yeah, the second area in the kind of field of ethics I want to touch on is kind of somewhat very practical and hopefully of use to you all. This is about publication, especially in research publication. I don't know if you've heard about this, but there is this observable trend, right? That scientific publications, they show like a very fast increasing share of texts that were written at least partly by using generative AI. This is one kind of analysis by a researcher from the University College of London. His name is Andrew Gray. This is one of the most recent kind of papers that I found, but there are many studies like this out there. Kind of what he does is a very classic old bag of words approach. Apparently, the scientific articles that are produced with generative AI, they overuse specific phrases or specific words to a high degree. And so he groups them into several groups. You can see up to group 10, where it's like how many of these words, of these weak, medium, strong words appear in an article. And you can see that for all of these groups, it's basically trending upwards. If you look at group 5, which is right in the middle, that's already kind of projected to be by the end of 2024, by the end of this year, at about 30%. So is that a bad thing or is that a good thing, right? That's the question. So as always, the answer is somewhere in the middle. You just mentioned people from different languages trying to publish in English because there's a much bigger audience for that. It's much easier to have your research, kind of spread out and people actually read your research. So for people that are not native speakers, having an assistant, whether that's a model, a machine, or a person, helping you with the phrasing of your article, that's actually a positive thing. And I don't think that we will get to a point where it will be kind of ostracized or even forbidden to use generative AI models to write texts, right? That's not the point here. But the more interesting and the more kind of challenging question is the question of attribution. So at what point should you put a label on this was generated with generative AI, right? And that's the kind of continuum where we are today and where it's difficult to say. There are no rules and there are very few good practices or good standards of research yet because this is so new, right? I want to read a couple of prompts to you just as a quick and dirty exercise, basically, that you maybe can do to figure out, okay, where do I draw the line, right? One prompt could just be rewrite this paragraph that I wrote. Probably nobody has a problem with that. You don't have to stick a label to that. Suggest 3 areas in which my research results can be applied. Probably also nobody has a problem with that, right? Write an interpretation of these outcomes of my analysis. Oh, that's a little more tricky, you know? An interpretation can be, am I even kind of understanding this interpretation? Does this kind of, you know, does this follow the lines of my thought? Is this something that is maybe wrong from my perspective or whatever? So this is maybe something where it's already kind of a question, okay, I should probably put a tag on here or mention this somewhere or whatever. And then you have analyze this data, define the relevant context, and write a scientific interpretation. Very clearly, that's not your own work anymore, right? But as you can see, there's just this continuum, and over the next couple of years, in every research field, in public publications and stuff like that, maybe even every journal, every website where you can publish stuff, they will come up with their own standards. And I think the best thing we can do is just kind of keep up a little bit, right? If you publish on certain websites or publish on certain journals somewhere, read up on their standards, you know, talk to your colleagues about this. This is a developing field. So partly we just have to kind of, you know, try and keep up with that. But I think there's also an interesting opportunity. For me, it's an exciting opportunity. We can also shape new standards here, right? When we talk to colleagues in our field, when we talk to people, when we read, we maybe talk to colleagues in a completely different field. How is AI handled here, you know? If you only read Nature and Science, you know, maybe pick up a philosophy journal and see what their regulations are. There's an interesting opportunity here to set the standards of good practice that we kind of, you know, or you as a community of scientists or we as an educated public want to follow. So this is a little bit of an appeal from my side to all of you. Be actively involved in this. You know, there's a lot of space to kind of set new guidelines here and to some extent impact the research of coming generations. Yeah, so that was all I had in the area of ethics. Any questions, any other use cases or areas that were not covered here? Let's move on to the third area. I've called this best practices. I think that's somewhat of an industry term. We use that a lot at Google, you know, technology industry. You can call it quality standards or standards of good research, research integrity, whatever you call that. I'm pretty sure you're aware of that, right? This is the biggest area, if you remember from my initial diagram. It's also the area maybe with the most gray color in there. A lot of this is sometimes unwritten, sometimes it varies between fields. It changes over time. It's partly influenced by the public. So again, I've just picked a couple of topics that I think will be very interesting and very important here. But if you can think of any other topics that you find relevant in this context, just bring them up. If you have any specific use cases or questions, then we can discuss them. Yeah, so I want to talk about something that I call research integrity. That's not the integrity that you bring as a person, as a researcher to your work, but the integrity of the outcome. We already mentioned the reproducibility. Yeah, that's kind of along those lines. And then the second part is, again, the philosophical concept, the so-called law of the instrument. Yeah, I stole this beautiful little illustration from a Nature article. Basically what it implies, right, it's if you slap AI on it, can you sell it as a cure for everything? It's hyperbole, but obviously sometimes you get the feeling, right, that if you slap AI on it, it sounds like a new paradigm, or if you slap AI on it, it sounds like a breakthrough or something like that. AI has been obviously transformational for many fields in science and technology in the public. You know, you don't get the Nobel for nothing, you know, for having no impact. But AI has also caused a lot of new problems or kind of opened up new challenges in fields of research, of technology, and in the public. And part of that is a blind trust, kind of, in the tool, in the technology itself. So where does this come in for research specifically? As we already mentioned, right, and as you probably all are aware, research in the last decades probably, there's something emerged that people call the crisis of reproducibility, or there are other names for it. One of the foundational principles of the scientific method is that people can check and verify or falsify research that we're doing, right? That's kind of non-negotiable. But part of what we have seen in recent decades, and AI actually has exacerbated that problem, is that there are studies, and quite a lot of them, where the results are actually not reproducible. So that has many reasons. I know in the social science, for instance, in the 2010s, there was this big hype of doing research on Twitter. It seemed an endless data source of sentiments and feelings and public expressions and stuff like that. Practically none of those studies that were done on Twitter feeds or on Twitter text messages in the social sciences were reproducible. So most of that was useless. Nobody could kind of verify or falsify that and build on that. It's probably less so in the numerical fields, but I know it's for a fact that, for instance, in medicine and fields like psychology, they have the exact same issue. So where does AI come in, or what's the specific role of AI in this? So AI actually kind of adds to this problem from a specific number of reasons. The first is AI algorithms are often proprietary. So we don't actually know how these, as I mentioned, we don't know how these models work. If you know, take ChatGPT 4.0, probably nobody in the world knows exactly anymore how this model works. If you put like 100 of these researchers in a room together, they could probably explain it at every stage, but still, that's part of the problem. Then proprietary data sets, we've talked about that already. It's very difficult to understand what data went into training a model. Then in the technology sector, kind of the continuous development is basically the method of the hour, which means the model that I'm using today is probably not the same anymore as the model that I'm using tomorrow. Most of the changes are very incremental, but even, you know, some medium-sized changes, they're not necessarily always announced. We think of these models as discrete kind of entities, right? ChatGPT 1, 2, 3, 4.0. That's not the case. It's a continuum. And whenever the performance is sufficiently new and upgraded, they call it something new. But that doesn't mean it's an entity that's always going to be the same. As I said, when I talked about documentation, actually writing down the date when you use a model can be very important to verify or falsify a result that you get from generative AI. For research, that puts us that generates a huge problem, because again, research is founded on the principle of being able to reproduce results and then build on them. So again, there is no good solution here at this point when using generative AI models. Documentation is one for certain. Transparency of writing down what you're doing, what you're using is definitely something else. But I think that in many fields, we will have to come up with new ways of making our research results when we use generative AI verifiable or falsifiable by other researchers, and find new ways in enabling other researchers on building on top of what we are doing, even though they might not be able to reproduce a certain result to a T. I have no idea what that is. But just again, I want to say, I also find this exciting, right? There are opportunities here to shape what the scientific principles will look like in the future. Doesn't mean we'll kind of, you know, just throw out all the old principles, but, you know, we're going to be part of that development. And there's a huge opportunity here for us as a public, for you as scientists, kind of, you know, to shape that field. Because in the end, if the research is unusable, nobody will quote that, right? And we know that already. Like, I don't know what 40–50% of all articles written there basically quoted less than 10 times if you look on Google Scholar, right? Partly that is a problem of the system, and it's the same in the private sector as it is in research. You know, you're kind of rewarded for output, not rewarded for, you know, being diligent and critical and maybe cleaning up stuff. Nonetheless, that's the research integrity, right? Doing that work, cleaning up the data, documenting what we're doing. It will just become a little bit more onerous when we talk about these large data sets and these large models. Yeah.
There's a question in the chat. How well are LLMs, commercial or otherwise, buffered against security breaches, manipulation, malign intent, and corruption?
Yeah, excellent question. Thank you. As I mentioned before, it's like with any antivirus programs, they're always behind. So whatever is implemented right now is dealing with what was relevant yesterday. It's not dealing with what's going to be relevant tomorrow. This is a huge and expanding field, though. Specifically, if anybody's interested in that research area, adversarial attacks on LLMs. That's a very, very interesting and promising field to be in right now.
Oh, there's a question online. Brian, go ahead.
Yeah, thanks. So I appreciate you talking about the the ways that researchers can try to add at least some artifacts of reproducibility, like putting in the date for when you put in a prompt, for example. But I guess when I think about it, like it seems like nobody, for at least for these large models, is going to at a later time is going to be able to access that model as it was when you made the prompt. Maybe not even the companies that are developing them. So it feels a bit like a placebo to me, but maybe I'm missing something.
No, you're absolutely right. It's very difficult to say at what stage companies take snapshots of a model and store that. And even if they do that, it's very questionable if they're going to give you access to that at some point. I think for now, the main purpose when this is kind of used is to kind of give an anchor point for comparison, right? If I gave a prompt, maybe not something trivial, right? Creating cartoon, that doesn't matter that much, right? But I have a data analysis and I have the model spit out an interpretation, or I have the model spit out 3 contexts where that's relevant, right? I can at least compare that to the output I get 3 months later, 6 months later, stuff like that. I can put in guardrails around my interpretation. If I see that this result, the output of a prompt changes every single day when I put it in, I should probably not use that result because there's something in that black box of the model that I'm not aware of. And unless I understand that, I should probably not use those results, right? This is mostly kind of dancing around that black box of a model that we don't understand. There is the hope, obviously, right, that with more regulation and maybe also just pragmatically with more compute, we will have more of these snapshots. We will be able to actually access these snapshots. Like ChatGPT, right, you can choose different models to use in their interface. Again, these are also artificial snapshots. It's not full entities that were built like that and will always remain like that. But that's a start. You can compare the output of ChatGPT 3 and the 1.0 model that's coming out, right? So most of this is trial and error at this point.
I have a follow-up question on this. So even the same command, if you put it twice in ChatGPT, you'll get 2 different answers, or at least that was the case a few months ago. So, like, how can we better, like, I know that they probably use a random seed that retrieves like different parts of the model, look at the different weights, but how can we cite them? Even like version of LLM would not be good enough to reproduce the same result output, the same code or the same content, even like the same minute.
Yeah, there's no good answer to that at some point. I know that Anthropic, for instance, they make the Claude models, right? They're kind of experimenting with something, I think they call it artifacts, where they have this additional window and sometimes they show the code. Like for instance, if you say generate an HTML graphic of this and that, it will show you the code on the side that is kind of used to generate that. And if you do that 5 times, you will see there'll kind of subtle differences between these, but most of the gist of it will be the same, right? And then you can differentiate between, okay, apparently these parameters in the model are fixed with this prompt and these parameters are not. Understanding something like that can help us already kind of gauge a little bit better, okay, this is more how this black box of a model works. This is how I can kind of document that and put it down for posterity if I want to use that in one of my scientific output. Part of the reason why documentation is highlighted in regulations and why I also have highlighted it here a couple times is obviously it's just a hope, right? That eventually we will have the ability to, as I said, go back to snapshots, or there will be any other creative or technological way when we can utilize that documented data and utilize these timestamps that we have had, or utilize kind of the comparison between different outputs. This is kind of, optimism. It's not necessarily required at this point, for sure. Go ahead.
There is another question in the chat. Can you talk a little bit on your thoughts on software licensing with code generated from LLMs?
Excellent question. There are probably some commercial regulations around that I'm not familiar with, right? I want to say, and you probably hear this more often around AI, if you're very uncertain, maybe it's time to consult your legal department. They might know. Although even for legal departments, right, the regulations they're evolving, it's difficult to keep up. It's a similar question, like, right? Why do people pay for books that are written by an AI? To some extent, if there is utility in the model that you've built, even if that's generated by an AI, I don't see any ethical reason why you should not do that. That being said, right, there's a difference between kind of, working with clickbait, trying, to extort people to buy something, or hiding that, or using any kind of shady commercial practices, right? Again, there's the spectrum, you can be kind of on the very safe side and just throw everything out and just make it open source. And you can be on the very shady side, and try kind of, questionable practices to get people to buy a license. And then there's a huge spectrum in the middle. Mostly this is on us, right, to develop the ethical standards, to develop ethical decision-making around this new technology. This field is in development and we are the ones developing it. Sorry if that's not a very satisfying answer.
Are there any, are there any guidelines on, like, for example, which open source license, for example, if you have generative AI codes, which open source license you can still put on your code?
I'm sure there are. Yeah, I wouldn't know them from the top of my mind, but I'm pretty sure if you, talk to the right people or even just do an online search.
Yeah, I guess a corollary for that would be very nice to say, can you generate me code that is LGPL 2.0 or better compliant, right? Do we have any idea if that's on the radar for the?
Oh, for sure.
Yeah.
100%. Yes.
So the models themselves should be able to generate code that's compliant with a requested license restriction, but we kind of have to trust it.
I think, though, that that's one of the more interesting use cases that's being developed. It's code generation is one thing, right? But code evaluation or code assessment, you write code and kind of, I know what my colleagues and I do at Google is we write code and we put it into a model and say, does it do this? Just check if there are flaws. But you could also write code and say, does this live up to these and these and these standards? And most likely, these models will be able to perform these assessments. If not now, then that's definitely on the roadmaps for everybody. Because that's one of the huge benefits of working with AI, right? It can retrieve information in highly complex data sets and apply them to very targeted use cases where you would find you have to find a human expert in many of these cases to give the same precise answer. Go ahead.
Yes, if you want.
Okay, sorry about that. There's a question in here from Gary that says, in a more general sense, does the use of an LLM at NCAR introduce a general risk to NCAR's intellectual property rights?
Yeah, very, very good question again. And again, for the detailed nuances of that question, you would probably have to talk to a lawyer. Intellectual property is one of the most contentious areas for generative AI, and for a reason, right? If you will, the main question is, or one of the central questions is, how closely does what you get out of the model resemble a very specific piece of training data that went in? Because unfortunately, sometimes the models actually do something like copy paste, depends on many variables in there. But if you get something out and it looks like it's 80% following a very specific example that's part of the training set, I would probably either not use that or label that or get a license or something like that. I don't know where the boundaries are for that. And normally the model builders, they are obviously aware of this, right? And they try to avoid that. They try to avoid having a single piece of input kind of just be kind of iterated through the layers and then spit out as the output again. But it will happen for sure. So that's definitely something to be aware of. Maybe, a good project would be to just build a database that assesses generative AI output based on how much it resembles what exists in the training data set. And that's something that might even come from these companies as well. Any other questions? The last topic that I want to bring up is a bit of a philosophical concept. So maybe I'm going to ask you just to humor me a little bit on this one. It's a philosophical concept called the law of the instrument. Pretty sure you've heard variations of this, right? It is tempting if the only tool you have is a hammer to treat everything as if it were a nail. This quote is attributed to a computer scientist called Abraham Maslow, but there are other kind of origin stories of this. And it's been a well-known concept in philosophy for many decades. What does it mean, though, in the field of generative AI? Normally, especially in technology, but also in science, right? We start with a problem. We see something, there's something that's not explained, or something that's unsolved, or there's a riddle there, or whatever, there's an incongruency. And then we develop tools that we need to use to solve this problem. With AI, it's actually been the opposite. There were very smart people and they realized there's a great opportunity to build a very, very cool tool. So this tool is out in the world now, but there's actually no good use case for that tool. So basically what we are all doing right now is it's a huge global experiment. We're trying to find good use cases for a tool that exists out there. There's a shiny new hammer and we need to find the nails that fit to that tool. There's actually even, just as we speak, there's a huge Kaggle competition by Google. Can win 25K if you find a good use case for Gemini 1.5. I'm not joking. That's how desperately everybody is looking for these use cases. What does that mean for using generative AI in our kind of research day-to-day life, right? In the normal use cases that we have? Well, as it says here, if our tool is a hammer, we try to tend to treat every problem like a nail. Generative AI has some very specific strengths and very specific capabilities, but it also has very obvious blind spots, very obvious things it cannot do. And if we apply that to any problem, we will find that some of generative AI's capabilities will fit that problem and some won't. And there will always be the temptation to tweak the problem in such a way that the tool fits the problem, right? And that is where I see personally one of the dangers of AI in the humanities, in science, but also for us as a public. We will start to tweak our questions that we have, the problems that we're interested in, the things that we are pursuing to fit this tool if we kind of start to over-rely on that. And that's not going to be very helpful, right? Irrespective of what the Nobel Committee might have thought, AI is a tool. It is not a new scientific paradigm. It's not a new paradigm at all. The math behind it is actually 200 years old. It is not innovative. It's not a breakthrough. It's just a new tool, right? For me, that's most important to keep in mind when I work with AI. There was a very fascinating study that was published on arXiv, like very recently. I'm not sure if you're all familiar. arXiv is a pre-publishing platform where articles are published before they're peer-reviewed, and it's been especially kind of popular among AI researchers because everybody wants to be very fast and kind of skip ahead of that whole review process. And there was a very fascinating study that still has to be confirmed, but still. Researchers, they were doing a meta study on human AI cooperation and human AI synergies, if you will. And they were kind of looking at tasks where either an AI performed the task, a human performed the task, or an AI-human kind of cooperation, if you will, perform the task. Interestingly enough, when the AI is slightly better than the human in solving this problem, when you compare them 1-to-1, then the quality of the cooperation will actually go down, will be worse than if you let either one of them do that. But if the human expert is better than the AI in solving that on their own, the synergy with the AI will make the output better, right? AI works if we know what we are doing. That's when it kind of, gives us superpowers. If we don't know what we are doing, AI will not be able to tell us. It will not be able to pull us up somewhere where we are not, right? So the best thing to do when we want to make good use of AI is be the experts in our fields, and then we can use that, right? AI does not kind of allow us to skip that whole education, that whole reading, talking to people, building our knowledge base, building our expertise, building our mastery. It will supercharge what is there. It does not kind of fill in the gaps. I find that very kind of comforting, actually. AI is not going to take away my job anytime soon, but it can help me be better at my job. That's cool. I like that. All right, that was all I had on the agenda. Thank you for your attention. I know we still have time. Does anybody have any follow-up questions at this point?
Yeah. The last point is very interesting. So so when it comes to education, so one of the main issues, like when students are submitting their thesis, and it's now becoming more and more difficult how we can evaluate their work, and maybe this kind of advancement is not encouraging to work harder on their thesis. So what's your suggestion, or what's your comment, like how we can handle this kind of emerging problems in the educational system?
Yes. I think that every teacher on the planet probably has asked themselves that question. There is an analogy that works to some extent, right? And that's the electronic calculator. When the calculator came up, obviously people were against that. They were saying, how can we evaluate people's math knowledge if they just type it in and then the machine spits out the answer? And then education adapted to that, and nowadays nobody would see the calculator as a threat to mathematical education. That being said, working with generative AI, that's a little bit different compared to a calculator, right? The capability set is just that much bigger. So it's going to be much more difficult to make that adjustment. To making the adjustment from doing math in my head or on a piece of paper to the calculator was not that big of a shift, right? It was a shift, though. It took, the education sector probably years or maybe a decade or so to kind of come to terms and find better ways to incorporate the calculator and then still find ways to evaluate students on their math capabilities. The same will happen with, education in the age of generative AI. I'm pretty sure of that. That's going to be, as I said, probably a bigger process, right? At this point, there is no established best practice yet for that problem, but there are very interesting approaches, right? Part of that is, when you evaluate students, you have to get them back into a classroom, take away computers, maybe let them write by hand or something like that. I know that some kind of liberal arts colleges in the US, they kind of, make it part of their honor code that students, kind of follow, that they don't use generative AI. That might be helpful in some contexts, but the tool is out there. So in my perspective, the better way to deal with this is to start find creative ways to incorporate that into the education process and teach students to deal with the tool, right? Maybe you let them write a paper using generative AI in a field that the models hallucinate, and then you show them afterwards, oh, you wrote all the stuff here that's completely untrue. How did that happen? And then you can kind of maybe start a fruitful discussion. That being said, I'm not a teacher most of the time, and I also find it hard to deal with that, right? I would encourage you, talk to other people, read online, right? Check up if there are any good practices. Are there any schools that are leading in this effort? Are there any kind of, teachers that have found very creative ways to incorporate generative AI into their teaching? Again, this is evolving field. It's very young, you know, it's just a couple of years. There are many, many questions that we don't have answers to yet.
Brian, go ahead with your question.
Yeah. Sorry, I'm trying to collect all my thoughts, but and I think your talk gets to this to a degree. But I was just thinking about, you know, a lot of obviously the large models and a lot of the technology and the infrastructure behind it is coming out of, you know, the large tech companies. Presumably, the people who work at the large tech companies have a lot of knowledge, you know, probably the best knowledge on using these tools effectively and maybe using them ethically. Um, is like, are there good places to go for somebody who's just sort of onboarding themselves and using these tools to get some of that, you know, shared experience from people who are working in industry? Like, is that being shared and publicized online, or is that considered more of like a trade secret or even a product?
Very, very good question. And I want to say, I very much hope that, you know, my colleagues at Google and at the other companies follow that ideal that you just mentioned, that they actually know how to use these models ethically. In reality, that's probably unfortunately not always the case. This is a little bit of a difficult field. If you have followed AI ethics, or, you know, even on the kind of larger scale technology and ethics, for many of the big companies like Google or Microsoft, you know, they build these ethical committees of supervisors, if you will, and then that clashes with some commercial kind of interests they have, and then they disband them again, and kind of, you know, try to give themselves guidelines, and then they topple them again. It's I mentioned at the beginning, right? There is this a little bit of this feeling of being in an arms race. These companies against each other, countries against each other, the West against China, and all these things, which makes it very complicated to have ethical kind of considerations be present. What I will say is that what I experienced at Google is that a lot of my colleagues, they do develop grassroots kind of movements, you know, speaker series, outreach programs, and some of that is public. So you can find that on YouTube or any other platform of your choice. There are publications, Substacks, blogs, articles. I mentioned this in a little conversation we had before the start. The interesting aspect of the whole AI field development to me is like it's not developing gradually like a funnel and becoming bigger. It was just an explosion, and now we kind of have to navigate this huge field that kind of came out of nowhere. A little bit. There are so many theories, speaker series, articles, opinions on how to deal with generative AI. That's very difficult. Many of them are written by generative AI models. That is difficult to kind of navigate. I know that, for instance, the University of Oxford, they have a very strong program. They have a very long-standing tradition of technology and ethics and technology and philosophy. They have very, very good researchers. They are one of my go-to kind of portals. There, I read their articles, for instance, and I find they have very helpful suggestions and actually quite good paradigms and practices that they suggest. I know that there are a couple of AI research institutes being founded at universities or, you know, nonprofits across the globe. And usually I find many of them are very earnest and very knowledgeable about this. So that's kind of partly what I follow, where I try to read. But yeah, if you come across something interesting, I would always encourage you, share it with your colleagues, share it with other researchers, you know, discuss this as a topic. This is an area where we kind of have to come together as a public, and as a public find our standing within this. It doesn't help if there are just like 5 researchers in the White House that publish an ethical paper. Nobody will follow that if that's kind of not embedded in what we do in our daily life.
I have a question. So in the past year, I'll say even in the past 6 months, some of these LLMs have become very, very powerful. And there are many different services, for example, different co-pilots that are now available for helping you with writing code. And at some point, and each one of them, of course, is a subscription-based service. At some point, this will become an issue of access for a lot of researchers at different institutes. For example, if there are like 10 different subscriptions of different AI tools that I need for writing a paper and doing analysis. So how can we make that more fair for everyone so that like at least everyone have access to some sort of tools for if we are advocating using these tools?
Yes, a very, very good question, and unfortunately, a very much unsolved problem. Maybe you've heard the term the digital divide, right? In the digital space, it's like it seems a divide is emerging between the haves and haves not, the people that have access to data sets, to models, to technology, and that supercharges their work, and then there are people that do not have that. Sometimes it's even just a question of education, people that know how to use these tools and people who do not. So I don't know of any kind of large scale programs at this point to bridge that gap, that digital divide. I know that in terms of public research, there are programs, right? Even some of these big tech companies, they have programs where you get access to the models at a huge discount. I know that there are funds like from public bodies, right, to you can apply to for specific projects and stuff like that. It's very cumbersome at the moment. You know, if you happen to be in the wrong side of the digital divide, to cross that gap, it's very cumbersome, and it requires, as far as I know, it mostly requires effort on your side. There's very little kind of structured help at this point. I'm pretty sure there are great opportunities as well for the public, but also for individual research institutions to help with that, right? Have partnerships with institutions that cannot afford that. Do education courses, you know, how to use that, generative AI 101, something like that. But yeah, there's a lot of work needed to bridge that gap for sure. And then, you know, this is the US, which is, you know, where many, many people are on the good side of the digital divide. If you think about research institutes in Latin American countries and Africa, right, for them, that problem is even bigger for sure.
Thank you so much. So do we want to stop recording? So if anyone wanted to ask a question that's not recorded in the video, they can do?